Now, good afternoon, all viewers. I'm just continuing the previous statistics class today also. In last class, we came to know about the skewness and kurtosis. Kurtosis means in Greek bulginess, but when we go for statistics, it tells us about the flatness or peakedness. Okay, and we'll have three types of kurtosis: Lipto, Plato, and Meso, kurtosis. When you take into a symmetrical distribution, when you take into account a normal distribution or a symmetrical distribution where the arithmetic mean, median, and mode coincide with each other, in that the kurtosis values, okay, the kurtosis value beta 2 is equal to 3. Beta 2 is equal to 3. If it is more than 3, it is nothing but positive kurtosis. If it is less than 3, it is negative kurtosis. And people, they will get a doubt. Sir, you are telling that beta 2 is equal to, okay, mu4 by mu2 square. What is this mu1, mu2, mu3, and mu4? They are nothing but the movements. They are nothing but the movements that we come across. And when you go for this beta 2, how to find out that? How to find out this mu1, mu2, mu3, mu4? I am giving the formulas for that. Mu1 dash, mu1 dash is equal to sigma fd dash by n. Okay, mu2 dash is equal to sigma fd dash square by n. Mu3 dash is equal to sigma fd dash to the power of 3 by n, and mu4 dash is equal to sigma fd dash to the power of 4 by n. These are the formulas that we come across. When you are given a distribution, first of all you have to calculate fd dash, f2 dash, okay, fd dash, fd dash square, fd dash to the power of fd dash cube, fd dash to the power of 4. All these things you have to find out, and all these things you have to divide with number of items, that is number of observations. Then you will come across some values, and we have to take into account mu1 dash, mu1 4 dash by mu2 dash, okay, whole square. That is the formula. And when the answer is less than 3, when the answer is less than 3, it is not, okay, the beta value, or it is called as Plato kurtosis, not mesokurtosis, not mesokurtosis. So B1, when you take into account skewness, B1 is equal to mu3 square by mu1 mu2 cube, mu3 square by mu2 cube. This is about the skewness value that we come across by using movements. Now kurtosis, B2 is equal to, as I already told you, mu4 by mu2 square, mu2 square. This is about the kurtosis value that you have to find out. When you are doing this, when you are doing this, you have to first of all test the kurtosis. For testing kurtosis, we compute the value of B2. When a distribution is normal or symmetrical, B2 is equal to beta 2 is equal to 3. When a distribution is more peaked than the normal, beta 2 is more than the value, and when it is less peaked than the normal, beta 2 is less than 3. It is more than 3 and less than 3. Beta 2 is equal to mu 4 by mu2 square. That is the thing. Now, when you want to go for the problematic portion, okay, you have to take into account the platykurtosis or mesokurtosis. Okay, for that you have to take into account again the beta 2. Beta 2 is equal to mu 4 by mu 2 square. That is the thing. And I told you already that the formulas to calculate mu 1 dash is equal to fd dash by n. Mu 2 dash is equal to fd dash fd square by n. Mu 3 dash is equal to sigma f cube by n. Mu4 dash is equal to sigma f to the power of 4 by n. These are the things that we will come across. And after that, you have to take into account the original formula. The mu2 is equal to mu2 dash minus mu1 dash whole square. Mu3 is equal to mu3 dash minus 3 mu1 dash. Okay, 3 mu1 dash mu2 dash plus 2 mu1 cube. Like this you will come across. And mu4 is equal to mu4 minus 4 mu1 dash mu3 dash plus 6 mu1 dash square mu2 dash minus 3 mu1 dash to the power of 4. These are the formulas that were given, okay, instead of going for calculation in them. In statistics, for BSc, you can go for proofs. Okay, you can go for proofs. That is, everyone, they have to see the proof. But when you are going for BCom, it is nothing but just application of the formulas, whatever it was given. Okay, so for any problem, you have to take into account, first of all, beta 2 value. Beta 2 value is equal to mu 4 by mu 4 square. That is the formula that we will come across. And when you want to know about this mu 1 value, mu 2 value, mu 3 value, and mu 4 value, the already told the formulas you have to take, you have to calculate. That is, you have to take fd dash square, fd dash cube, fd dash to the power of 4. All these values you have to come out, you have to see, and then you can go for beta 2 value. Okay, now after that we are going for correlation. What is correlation, sir? Correlate. In practical life, we come across a large number of problems involving the use of two or more than two variables. If two quantities vary in such a way that movements in one are accompanied by movements in the other, these quantities are correlated. These quantities are correlated. That is, you have to bring that. Here, when you are going for that, you have to take into account the variables. You have to take into account the variables as well as the distributions. And if one value is changing, the other will also change. When they are doing that, then only we can see the correlation in that. Then only we can say that there is correlation in that. So when they won't change, when you won't come across any changes by changing one variable, the other, if you won't see any changes in the second one, then we can say that they are not correlated with each other. So when they will come, when the movement of one, when it is accompanied by the movement of the second one, then only we can say that there is correlation. So correlation, the degree of relationship between the variables under consideration is measured through the correlation analysis. So the degree of relationship between the variables, how they are related with each other, For example, if you take into account a change in a person, when it brings a change in another person, then we can say that they are correlated. When a change in a person, when it does not show any difference, any change in other person, then you can say that they are not correlated. They are not correlated. So they are having their own individuality. Okay, this thing you will observe in your general life. This thing you will observe in general life. But the thing is, keen observation must be there. When you don't have the keen observation, you can say that there is no correlation. So the degree of relationship among the variables, okay, we have to take into account. The measure of correlation called the correlation coefficient, okay, or correlation index, summarizes in one figure the direction and degree of correlation, that is nothing but relationship. The direction and degree of correlationship that we will come across. So here correlation is represented by small letter, small alphabet R. Okay, and there are two methods for finding out this correlation. Okay, there are two variables, the various methods ascertaining whether two variables are correlated or not are scatter diagram method, graphic method, Karl-Pearson's coefficient of correlation, and the fourth one is concurrent deviation method, and the last one is method of least squares. The first two are based on the knowledge of diagrams and graphs, whereas the others are the mathematical methods. That is, first two, that is scatter diagram and graphic method, these are nothing but the graphic representation method. Karl-Pearson's coefficient of skewness, concurrent deviation method, and the method of least squares, they are all nothing but the mathematical methods. Now, out of that, the best one that we are going to study now is Karl-Pearson's coefficient of correlation. It is also known as Pearson's coefficient of correlation. Pearson's coefficient of correlation. Now, according to Karl-Pearson's coefficient of correlation, R is equal to small r. Don't forget. Don't write big R, please. Small r is equal to sigma xy by n into standard deviation of x into standard deviation of y. Okay, standard deviation of x into standard deviation of y. So you have to take into account the x value. X is equal to x minus bar x. Y is equal to small x, please. Don't go for big X. Small x is equal to big X minus bar x. Similarly, small y is equal to big Y minus bar y. So that is the thing that we'll come across regarding the formula. And sigma x, standard deviation of x series, sigma y, standard deviation of y series, n is equal to number of items, number of pairs of observations. And when we are going for this, for small numbers we can able to find out the standard deviation of x as well as standard deviation of y. But when the observations, when they are big, it is difficult for us to calculate. That's why the formula was transposed into, okay, R is equal to sigma xy by square root sigma x square into sigma y square, where that is small x, please. Don't go for big X. Okay, small x sigma xy, that is nothing but covariation. That is covariation. Sorry, not covariation. Sum of product of deviations taken from actual mean of x series and y series. And small x square, sigma small x square, that is sum of square deviations taken from actual mean of x series. And similarly, sigma y square is equal to sum of square deviations taken from actual mean of y series. So the formula is, okay, R is equal to sigma xy by square root small x square into small y square. This is the formula, transposed formula from the big formula. When we are doing the problematic portion, R is equal to this formula, that is nothing but transposed formula we have to use. That is sigma xy by square root small x square into small y square. That is the formula that we will come across. Okay, now this thing we'll use when we are taking deviations from actual mean. Suppose if actual mean is in decimals, if they are in decimals, it is very difficult for us to take the deviations. Then we have to go for another formula, that is when we are taking into account the assumed mean formula. When we are going for assumed mean formula, okay, we'll have two formulas. We have two formulas, that is n into r is equal to n into sigma xy minus sigma xy into sigma y by square root n into sigma x square minus sigma x whole square into square root n into sigma y square minus sigma y whole square. Okay, this is the formula that we'll come across. And when deviations are taken from assumed mean, when deviations are taken from assumed mean, not actual mean, please. Okay, then the formula is R is equal to n into sigma dx dy, sigma dx dy minus sigma dx into dy whole by square root n into sigma dx square minus sigma dx whole square into n into sigma dy square minus sigma dy whole square. So please don't get yourself confused. Please don't get yourself confused. This is the previous one is a direct method without taking any deviations. Now this method is when we are using actual mean instead of arithmetic mean. When we are using actual mean, assumed mean, this formula is very useful. That is, once again I'm repeating that. Okay, R is equal to n into sigma dy square into sigma dx dy, not, okay, once again I'm repeating, sorry, R is equal to n into sigma dx dy minus sigma dx into sigma dy whole by n into sigma dx square, n into sigma dx square minus sigma dx whole square into n into sigma dy square minus dy whole square. This is the formula that we'll come across when we go for assumed mean. Okay, now we are going for the problematic portion, or the d sigma dx dy. What is this, sir? Sum of the products of the deviations of x and y series from their assumed means. Now sigma dx square, what is this? Sum of the squares of the deviations of x series from an assumed mean. Sigma dy square, sum of the squares of the deviations of y series from an assumed mean. Sigma dx, sum of the deviations of x series from an assumed mean. Sigma dy, sum of the deviations of y series from an assumed mean. This is how the explanation of that formula is. And this formula, when we go, we have to take into account the assumed mean but not the actual mean. And previously whatever formula that I told, it is just a direct method without taking any deviations. Okay, you can apply any method, you can apply any method. Okay, when you are going for arithmetic mean, and when the arithmetic mean is in rounded figures, you can apply the small formula. No sir, we are not going to take the deviations, we want to do, I mean directly, means you can go directly. And suppose if the actual deviations in fractions, that is in decimals, then you cannot take deviations. Moreover, deviations will be very large and it is very difficult for you to calculate, and it is also a time taking. In that case, what you have to do is you have to apply the assumed mean method. So when you go for assumed mean method, compulsory you have to do this. This is how you have to do the correlation aspect. And with this, I'm stopping, and remaining portion tomorrow I'm going to continue. Thank you.